So the question related to topic momentum and the collision. Question 4. You can use the chat to answer the question. Question 4. So in this question, a ball of a mass m with a velocity v. So the ball is there, which is having a mass m, and it has a velocity v. It hit same direction, it like same speed but in opposite direction. So because velocity is a vector quantity, so we'll consider as minus v, and the time for the impact or the collision is t. Which of the following is average force or a mean force? So we know force is impulse divided by time. Impulse is a change in momentum. How we can work out the change in momentum? Here the momentum is mv, and here the momentum is minus mv. So the change in momentum minus mv minus mv, because it's a final minus initial. So final is minus mv minus the initial is mv. So it is minus 2 mv. That is the impulse. So the impulse is minus 2 mv and divided by time. So minus 2 mv divided by time, that will give us the value for the force. So with reference to that, D should be the right answer. Is it clear? Okay. The electron has a momentum of 1.9 exponent minus 24, the kinetic energy. How to get the kinetic energy? What is the relation between the kinetic energy and the momentum? So we have the formula that EK, you have to remember this, EK is equals to P square over 2M. The mass of the electron will be given in exam. You don't have to memorize. I will mention here. So you just have to substitute the values. The momentum is given to us. The momentum is 1.9 into 10 to the power minus 24, then square, divided by 2. And what about the mass of electron? The mass of electron is 9.11 into 10 to the power minus 31 kg. So when we simplify, what's our final answer? 1.92 exponent 24 square divided by 2 divided by 9.11, because the mass of the electron is 9.11 into 10 to the power minus 31 kg. What's the answer? So we got 2 exponent minus 18, so B will be the right answer. So this is a direct question. You just have to substitute the value and get the moment. Question 6. Remember, for any kind of collision, momentum and total energy should be conserved. It's only the kinetic energy which decide whether a collision is elastic or inelastic. So when we talk about the conservation of the momentum, like collision, type of collision can be elastic, or if it's an elastic collision, the kinetic energy is also conserved before and after same. Momentum and total energy is always conserved irrespective of what kind of collision we have, like elastic or elastic. Only the kinetic energy is a factor which can distinguish between elastic and inelastic. In elastic collision, the kinetic energy is also conserved. If we have inelastic collision, then the kinetic energy will not be conserved. So the correct answer for this one is A. Next question. In this question, a particle Z has a kinetic energy E and the momentum P. A second particle has a twice mass and a half the momentum. Half momentum of Z. What is the kinetic energy of X? So how we can work out? Look, for particle Z, if you have a particle Z, it has a kinetic energy E and the momentum P. And the mass example is M. So we have the formula that the kinetic energy is equals to P square over 2M. That's the formula. Now we have another particle which is X, has a twice the mass. So what is the relation between a kinetic energy and the mass? It is inverse. So if the mass is twice, what happened to the kinetic energy? The kinetic energy decreases by 2 because inverse relation. And what is the relation between a kinetic energy and the momentum? Kinetic energy is proportional to momentum square. It has a half momentum. If the momentum is divided by 2, what happened to the kinetic energy? It will divide by 4 because it is a proportional square. So if it is double, it will increase by 4. If it is half, it will decrease by 4. So what is the overall change in the kinetic energy? Because of the change in the mass, it is decreases divided by 2. And because of the change in momentum, it is divided by 4. So when we simplify this, EK by, because 2 multiplied by 4 is 8. So it will become 1 by 8th of the original. So that's why C will be the right answer. Is it clear, this one? Any doubt in question 7? Okay. The next we have the question is an object moving north with a momentum of 23 collide with an object moving east with a momentum of 35. After the collision, the object move off together. They move together means which of the following will give the magnitude of the final momentum? So, like, because we know according to conservation of the momentum, momentum before must be equals to momentum, like the sum of the momentum before is equals to sum of the momentum after. So sum before will be equals to sum after. How to add up this? So I can draw any of the vector first. I can draw horizontal first. So let's say I will draw 35 first and then 23. So this will be 35 and this will be 23. So what is the resultant of trail of the first to the head of the last? That will be the resultant, like that will be the initial, like the sum initial equals to sum after. So this is the sum of initial and after will also be same as the momentum is conserved. So because it is making a right angle triangle, for a right angle triangle, the resultant is a hypotenuse. So we can use a Pythagoras theorem, Pythagoras. So it will be 35 square plus 23 square in a root, because base square plus perpendicular square in a root, that will give us the resultant. So what is the resultant? So D will be the resultant. The magnitude of the resultant, I mean. So correct answer for this one is D. Next question, question 9. Two objects collide and rebound. Select the row of the table that is correct for the total momentum and total kinetic energy. For inelastic collision, so total momentum is always conserved. So either A can be an answer, B, but total kinetic energy is not conserved in inelastic collision. That's why correct answer for this one is B. Now, this is a similar question. Like actually, it's a second part of that same question, which we did question 8. Like we have the two momentums. What could be the resultant and the magnitude of the, how we can find the direction of the resultant. So what could be the right answer here? Because as we do the resultant, which of the following give a direction of a final momentum? Look, if we add the vector, like we have a 35 and 23 is there. So we know the result, the final vector will be like this. So it cannot be C or D are totally wrong. So either A can be an answer or B. And what about the angle? The angle from a north is given to us. So if this is our final vector and the angle from the north is given to us. So what is this? This will be 23. So this will be 23 and this will be 35. Okay. Now we know with an angle is the base and opposite to the angle is a perpendicular. So we have the tangent theta. Tangent theta is perpendicular divided by base. So according to option A, the perpendicular is 35. So I can write tangent theta is equals to 35 divided by base is 23. And what about the theta? Theta will be equals to tan inverse 35 divided by 23. So if this was the case, we are taking angle. So the base is, for us, the base is 23 and the perpendicular is 35. So it should be tan inverse 35 over 23. So when this is not written correctly, so that's why B will be the right answer for this. Is it clear? Discussion? So in the question, they need the angle from the vertical. Let's say if they ask us the like example, if this was the same question given, okay, and the angle from the horizontal, like this was a resultant given, and the angle from the horizontal was given to us. If this angle theta was given, so in that case, what we'll have, this will be 23, and this will be, sorry, this will be 35. According to the question, so the 35 is in this way, so this is 35, and this will be 23. So if angle from the horizontal is given, so this is a base for us, and here is a perpendicular. So when we use a tangent theta, perpendicular divided by base, so it will be 23 divided by 35, or theta will be tan inverse 23 over 35. So if the angle from x-axis was shown or given in the question, then this will be the answer. But its angle from the vertical is shown to us or given to us. That's why we took other way around. Is it clear? So it totally depends on the perspective, which direction or which angle you are taking. Next question. When we say non-relativistic particle, because you will learn this in particle physics, when the particle tend to move close to speed of the light, their mass does not remain constant, and we call that as a relativistic effect. So when we say the non-relativistic particle, it means when it is moving, its mass does not change. Because usually what happens when the particle tend to move close to speed of a light, their mass do change. So we have the formula that Ek is equals to P square over 2m. Another particle has a mass twice. So what is the relation according to this? The mass and kinetic energy are inversely proportional. The term relativistic mean, you will learn that in particle physics. The term relativistic means that when particle move close to speed of a light, their mass increases. But when we say non-relativistic, it means when the particle is moving, its mass does not change. That is a concept. So relativistic means when particle move, its mass changes, we call relativistic effect. If a particle move and its mass does not change, we call non-relativistic effect. So the mass and so in the question, the mass is double. So if the mass is double, what happened to kinetic energy? It will be half. And the momentum is also half. If the momentum is divided by 2, what happened to kinetic energy? It will divide by 4. So due to change in mass, it divided by 2. Due to change in momentum, it divided by 4. So what is the overall change? It will become 1 by 8 of the original value. So A will be the right answer for this. Is it clear, this one? So this is about the topic momentum. Next session, we'll do some structure questions from this. Tomorrow session, we'll do like the thermal physics as we completed. So we'll start the simple harmonic motion. That is a unit 5 topic. Any question or doubt related to the session today?